Welcome back to the deep dive. I want you to picture a scenario. It's Monday morning. You've just been handed the reins to a brand new AI initiative. The budget is approved. The executives are, you know, they're buzzing with excitement, and your engineering team is practically vibrating.
Oh yeah, they're ready to go.
Exactly. They are ready to download libraries, spin up GPU clusters, and just start training models. The energy is infectious. You feel like you need to move, right? You got to show
And
progress.
that right there, that specific feeling of we need to move, we need to build that is the sound of a project preparing to drive straight off a cliff.
Wow. Okay, that is a grim start. We're like 30 seconds in and we're already crashing.
It sounds dramatic, I know, but in the world of artificial intelligence project management, it's statistically accurate. Depending on which study you read, somewhere between 70 and 80% of AI projects fail.
That's massive.
It is. And here's the kicker. They don't fail because the math was wrong. They don't fail because the Python code had a bug. They fail because they completely skipped the starting line.
So they basically started running before they even knew where the race was taking place.
Exactly. So today, we are diving deep into Phase I of the CPMAI version 7 framework. That's business understanding. And look, I know what some of you are thinking. I can hear the listeners now. Business understanding, that sounds like corporate fluff. I tuned in to learn about neural networks and large language models.
Yeah, it does sound a bit like the eat your vegetables portion of the meal.
It totally is. But if you don't eat these vegetables, you starve. This phase is your insurance policy. If you are studying for the PMI-CPMAI exam, or if you just want to keep your job when that AI project launches, this next hour is critical. We aren't here to just read you a checklist.
Right, nobody wants that.
No, we want to give you the mental model so that when you face a scenario question on the exam, the answer just feels obvious.
So let's zoom out for a second. Where exactly does Phase I sit in the CPMAI lifecycle? Because CPMAI is iterative, right? It's a circle.
It is a circle, or a spiral, really. You go around and around refining the model. But Phase I establishes the absolute center of that circle. It defines the business objectives, the success criteria, and the feasibility. If you don't nail this down, you can iterate as fast as you want, but you're just running in circles in the desert.
Okay, so for the students listening right now, where do we find this in the ECO, the examination content outline?
You're going to find the bulk of this under Domain 2, Task 2, which is labeled Executing the Business Understanding Phase. That is your home base for this. But, and this is a really critical but that trips people up, it is heavily intertwined with Domain the 6.
Domain 6 being Trustworthy AI.
Right. Trustworthy AI.
Which is interesting because I usually think of trustworthy or ethical AI as something you check at the end, like a safety inspection before you hand over the keys to the car.
That is probably the single most dangerous misconception in the entire industry today. You absolutely cannot inspect in ethics at the end of a project.
Why not?
Well, if you train a model on biased data, that bias is literally baked into the mathematical weights of the neural network. You can't just patch it later with a quick software update. You have to define what trustworthy means for your specific context right here at the very beginning in Phase I.
Okay, point taken. Ethics starts on day one. Now, before we get into the specific task groups of Phase I really want to grapple with a concept that kept popping up in the source material. It looks like a terrible Scrabble hand. D-I-K-U-W, the D-I-K-U-W pyramid.
Yes, the fundamental hierarchy of value.
So why are we talking about this? Because we keep hearing, data is the new oil. If I have the oil, why can't I just start the engine? Why isn't having a massive hard drive full of data enough to start an AI project?
Because crude oil ruins your engine if you don't refine it first. The DIKUW pyramid explains that refining process. At the very bottom, the wide base of the pyramid, you have data.
Give me a concrete example. I need something real, not abstract.
Okay, sure. Let's imagine a traffic camera on a highway. Data is just the raw feed. It's just pixels. Red, green, blue values changing 30 times a second. Or maybe it's a sensor reading on the road that just says 55. Just the number.
Okay, so the number 55 is data. It's completely meaningless on its own.
Right. 55, what? Miles per hour? Degrees Celsius. Number of cars? We have to move up a layer to information. Information is data with context applied to it. So now it becomes the car is moving at 55 miles per hour. Now we have a complete sentence.
Okay, I can visualize that. That makes sense.
Then the next layer up is knowledge. Knowledge is where we start to aggregate that information and find patterns. We look at the history of that specific road and we know, hey, the speed limit here is 35 miles per hour. Now we have a comparison. We have context against rules.
So data is 55, information is 55 miles per hour. Knowledge is 55 is illegal here.
You're getting it perfectly. Now, the next two layers are where AI actually lives. The next layer up is understanding. This is the why. Why is the car going 55 in a 35 zone? Maybe it's an ambulance. Maybe it's a getaway car. Maybe the driver is having a medical emergency. Understanding infers the cause behind the knowledge.
And the very top of the pyramid.
Wisdom. Wisdom is the decision. What do I actually do about it? If it's an ambulance, I do nothing. If it's a reckless driver, I issue a ticket. If I'm an autonomous vehicle sharing that road, I pull over to let them pass.
So why does this DIKUW concept matter so much for Phase I?
Because stakeholders constantly come to you with data. They say, we have terabytes of customer logs, and they immediately expect wisdom. They say, we want to automatically retain all our best customers. They completely skip the middle steps.
Ah, I see.
Yeah, Phase I is about mapping that climb up the pyramid. If you don't know which specific decision, which piece of wisdom you are trying to automate, you are literally just hoarding data. You aren't doing AI.
That's actually a really great way to filter requests. If a stakeholder can't explain the wisdom layer, like what actual decision they want the machine to make, then you aren't ready to start coding.
Precisely. You're just playing with data at that point, which is fine for analytics, but it's not an AI project.
All right, let's get to work on the actual tasks. The CPMAI framework breaks Phase I down into task groups. The first one is marked HIGH priority. That is, Task Group 1, determine business objectives.
This is the bedrock of everything.
The very first task is literally called determine business objectives. Now, I've been in corporate America a long time. This honestly sounds like, hey, let's have a kickoff meeting. Is it more than that?
It is significantly more than that. And for the exam, you need to really key in on the word determine. It implies a formal, documented output. A vague verbal agreement in the hallway is not an objective.
So saying something like, I want to use AI to make our marketing cooler, that is not an objective.
No, that's a wish. An objective needs to be highly specific. Something like, we need to increase the conversion rate of our email campaigns in the Northeast region by Q3. That is a concrete business objective.
Why are we so incredibly strict about writing this down? I mean, shouldn't the team just know what they're building?
Because human memory is fluid. We call this scope creep via amnesia.
Scope creep via amnesia, I like that.
It's deadly. 2 months into the project, the data scientist thinks she's building a tool to predict what a customer will buy. But the VP of sales thinks she's building a tool to predict when they will buy. Those are two entirely different mathematical problems.
And I'm guessing they require completely different data, too.
Completely different data. If you don't have the objective written down and signed off by everyone, you end up building a bridge that meets in the middle of the river but at two different heights. It's useless.
Which leads us directly into task 2, determine business success criteria. I feel like this is where a lot of people get tripped up. I often see teams treat objective and success criteria as synonyms.
They are definitely cousins, but they're not twins. And mixing them up is a classic distractor on the exam. You have to know the difference.
Break it down for us. How are they different?
The objective is the destination. For example, I want to lose weight. The success criteria is the specific, measurable metric that tells you you've actually arrived. I want to lose 10 pounds by July 1st.
Okay, that makes sense in plain English. But in an AI context, where does that go wrong?
It goes wrong when teams confuse technical success with business success. This is huge. I see this cause failed projects constantly out in the real world.
Give me a war story. What does that look like?
Okay, here's a real one. A fraud detection system for a major bank. The data science team works on it for months. They come back into the boardroom and say, great news, everyone. Our model has 99.9% accuracy.
Sounds amazing. Break out the champagne.
You would think so. But then the business stakeholder asks, okay, but how many fraud cases did we actually stop this month? And the engineering team gets quiet and they say, well, the model flags them perfectly, but the alert system to the call center is broken, so we stopped 0.
Ouch. So the technical success was 99.9%, but the business success was 0.
Exactly. For Phase I, the CPMAI framework explicitly demands business success criteria. At this stage, we do not care about your F1 score or your area under the curve. We care about real-world impact. Did we save money? Did we save time? Did we save lives?
So I see a question on the exam asking for business success criteria. And one of the multiple choice answers is, model achieves 90% precision. That's a trap.
It is a massive trap. That is an acceptable model performance value, which is a different task that comes later in Phase I. It is absolutely not the business success criteria.
That is a crucial distinction for everyone listening to remember. Let's move to task 3, cost-benefit analysis. the money conversation.
Yeah, you cannot skip this one, no matter how much you want to.
I've worked on so many tech projects where we kind of wave our hands at this part. We just say, well, AI is the future. The ROI will be infinite eventually. We just can't measure it yet.
And those are the exact projects that usually get canceled by the CFO about 6 months later when budgets get tight.
Right. So how do we get real about this in Phase I when we haven't even looked at the data yet?
You have to estimate. And yes, everyone knows it is an estimate, but you must quantify the cost of the problem you are actually trying to solve. If you are trying to use computer vision to fix a manufacturing defect on an assembly line, how much is that specific defect costing you today? Is it $1 million a year, or is it $100 a year?
Because if it's only costing you $100 a year and the AI system costs $50,000 to build,
And you stop. You kill the project immediately. And frankly, that is a huge success.
we are definitely going to come back to that idea of killing the project as a success at the end of the show.
Mm-hmm.
But there is a very specific metric mentioned in the EKO here that I want to highlight. Time to ROI.
Yes. It's not just a question of will we make money eventually? It's a question of when. AI projects are incredibly front-loaded. You spend a ton of money on data cleaning, labeling, and training compute before you see a single dollar of actual business value.
So your return on investment curve is deep in the red for a long time.
Correct. The time to ROI calculation tells the business exactly what to expect. It says, hey, we will be in the hole for 14 months. Month 15 is when we finally break even. If the business needs cash flow next quarter to survive, this project is an immediate no-go.
The psychological trap here is the sunk cost fallacy, isn't it?
It absolutely is. People say, oh, we've already spent so much time talking about this, let's just keep going. Phase I forces you to look at the cold, hard math before any emotional attachment to the project sets in.
Moving on. We know what we want, the objectives. We know how we measure it, the success criteria. Now we hit Task Group 2, Cognitive Project Requirements. This is also marked as a HEH priority. The source material refers to this specifically as the CPMAI differentiator. Why is that?
Because up until this exact moment, everything we've discussed, the objectives, the ROI, you would find that in PMP, Prince2, Agile, whatever. It's just standard project management. Task Group 2 is where we start treating this like a standard software build and start treating it like what it is, a cognitive system.
Task 1 in this group is Cognitive Requirements. What does that actually mean in practice?
It means asking, what is the brain actually doing here? We are trying to replicate a human cognitive task with a machine. Is that task reading a document? Is it seeing a defect? Is it hearing a voice? Is it predicting a trend? You have to classify the exact thought process you're trying to automate.
Which leads right into my favorite debate in the entire industry right now, the automation versus AI decision.
This is the single most critical filter in Phase I.
Let me play devil's advocate for a second. Let's say I'm a CEO. I read about ChatGPT in the news. I want AI in my company. I want it everywhere. I want an AI to sort my emails for me.
Okay. I would sit down with you and ask exactly how do you want them sorted? What's the logic?
Well, if the subject line contains the word invoice, I want it sent directly to the accounting folder.
Then you absolutely should not build an AI for that.
Why not? It sounds smart.
Because it's massive overkill. If you can write a rigid rule, if subject contains the string invoice, then forward to accounting that is automation, not AI. It is deterministic, it works 100% of the time, and it costs about 2 cents to run.
And an AI solution.
AI is probabilistic by nature. It might get it right 99% of the time. But why in the world would you accept a 1% error rate and pay $50,000 to train a model when a 3-line script does it perfectly for free?
So Phase I is really about actively disqualifying projects from being AI.
Absolutely. If you can solve the problem with a spreadsheet formula or a basic logic script, do not build a neural network. You only need AI when the rules are simply too complex to write down manually. Take recognizing a human face, for example. I can't write a standard software rule for what a face looks like. It's too variable. Lighting changes, angles change. That requires AI.
That is a phenomenal rule of thumb. Can I write the rule? If yes, it's automation. If no, it's AI.
Exactly. Keep it simple.
Task 2 is AI pattern identification. The CPMAI framework lists 7 specific patterns. Things like recognition, conversation, predictive analytics, and so on. Why do we need to label the pattern this early in the project?
Because the pattern dictates the data you need. And the data dictates your entire feasibility.
Explain that connection for me.
Sure. Let's say you sit down and you think you have a classification problem. You say, I want to group my customers into high-value and low-value buckets.
Okay, seems straightforward.
So you go out to your data warehouse and you collect millions of rows and columns of customer spending data, numbers, dates, transaction amounts. But then midway through the project, you realize you actually want to know how those customers feel about your new product line. That is a recognition problem, specifically sentiment analysis or maybe a conversation problem.
And for sentiment analysis, I need text, I need their emails, I need support chat logs.
Exactly. And you didn't collect any of that. You collected transaction numbers. Now you have to throw out your work and go all the way back to the beginning to get the right data.
So misidentifying the pattern basically guarantees you're collecting the wrong ingredients.
And you definitely cannot bake the cake with the wrong ingredients.
That brings us really nicely to task group 3, assess situation. This one is rated medium priority, but I feel like medium in CPMAI still means ignore at your own peril.
Oh, absolutely. It's medium priority relative to the critical tasks we'll talk about in a minute. But if you skip it, your project stalls out immediately. This is where we stop looking at the pure idea of the project and start looking at the harsh reality.
Task 1 here is resource requirements. Now, usually when tech people talk about resources, they mean hardware. How many GPUs do we need? How much cloud storage are we spinning up?
That's definitely part of it, specifically the compute availability. But in phase I of an AI project, the most critical resource assessment is actually your talent.
The people on the team.
Yes. And the source material makes a really important distinction here that you absolutely need to know for the eco. It clearly distinguishes between data scientists and citizen data scientists.
Break that down for me. What is the practical difference?
A data scientist is your deep, heavy-hitting technical expert. They usually have a master's or a PhD in statistics or mathematics. They write custom code in Python or R. They can build a deep learning model entirely from scratch. A citizen data scientist, on the other hand, is a power user. They might be a brilliant business analyst who is really good at Tableau, or maybe they know how to use a drag-and-drop auto ML platform.
Why does that specific distinction matter so early, right in phase I?
It goes right back to the cognitive requirements we just talked about. If you decided in Task Group 2 that you are building a highly customized computer vision model to detect microscopic anomalies in an MRI scan, a citizen data scientist simply cannot do that work. You need the heavy hitters. You need real data scientists.
But if you decided you're just doing some predictive forecasting on next month's sales based on a really clean, structured spreadsheet,
Then, a citizen data scientist using an off-the-shelf AutoML tool is totally perfect. In phase I, you are explicitly obligated to assemble the project team. You have to match the required talent to the specific task. If you don't have the right people available, you don't actually have a project.
and then there's task 2, schedule requirements.
This one feels pretty standard, right? Every project in the world has a schedule.
Sure. When is it due? It's project management 101.
True, but in AI, the massive trap is letting the data science team dictate the schedule based purely on their own scientific curiosity. You ask them when it will be done, and they say, oh, we'll be done when the model is perfectly optimized.
Which, in data science, could literally be never.
Exactly. There is always another tweak to make. Phase I requires capturing business schedule constraints. You have to say, we need this live before the Black Friday shopping season, or we need this deployed before the Q3 regulatory audit. These constraints act as a vital forcing function.
So it forces them to stop tinkering.
It tells the data team, look, you do not have time for absolute perfection. You only have time for good enough by October.
Which is a perfect segue into defining what good enough actually is. Task Group 4, AI System Performance and Operation. This is marked high GH priority.
This is a fun one. This is where we actively bridge the gap between the suits in management and the geeks in engineering.
Let's look at Task 1, acceptable model performance values. This is the purely technical stuff, right?
Yes. This is where you define metrics like precision, recall, F1 score, false positive rate, the heavy math.
Why are we defining these mathematical thresholds all the way back in phase I? Shouldn't we wait to see how good the training data actually is first? Maybe we just can't physically get to 90% accuracy.
That right there is the moving goalposts danger. If you wait until phase 4, which is model evaluation, to decide what good looks like, you are begging for a massive fight. The data scientists will look at the results and say, hey, 80% is amazing given how messy this data was. And the business stakeholder will say, 80% is garbage, it's useless to me.
And then the project just completely stalls out.
Right. You have to define the threshold right now in phase I. You agree, we need 85% accuracy to proceed to production. If we can't hit it during training, we do not deploy. End of story.
There's a really specific scenario tip in the study material here that I love. It says, Accuracy is not always the right metric.
Oh, this is a classic exam concept. Imagine you are building a predictive model to detect a highly rare disease, a disease that only 1% of the global population has.
Okay, I'm with you.
If I am a lazy programmer and I write a simple script that just outputs "you are healthy" to absolutely every single patient who walks in the door, how mathematically accurate is my model?
Well, if only 1% are actually sick, and you say everyone is healthy, you are mathematically right 99% of the time. So your accuracy is 99%.
Exactly. I have a 99% accurate model, and I just killed 1% of the patients because I missed every single actual case of the disease.
So accuracy is a terrible, dangerous metric in that scenario.
Horrible. In that specific case, you don't care about overall accuracy. You care about recall, which is also known as sensitivity. You want to catch 100% of the sick people, even if you accidentally flag some healthy people as sick and make them take a secondary test. In phase I, you have to sit down and explicitly state, we care about recall, not accuracy. If you don't do that, your engineering team will optimize for the wrong mathematical target.
That leads directly to task 2 in this group, acceptable KPI performance values. Now, we talked about business success criteria briefly back in task group 1, but let's formalize it here. Why do we need both model performance and KPI performance documented?
Because the mathematical model is not the business itself. Think of it this way. Model performance is the RPMs of the internal engine. KPI performance is the actual speed the car is traveling down the road.
Give me a real-world example of where those two things diverge.
Let's go back to the customer churn example we mentioned earlier. You build a predictive model to figure out which customers are going to cancel their subscriptions. Model performance says, we can predict who will leave with 95% accuracy. That's a fantastic technical performance.
Right. Sounds like a huge win.
So the system goes live, it flags a customer, it says, John is going to quit this week. The marketing team has an automated system that immediately sends John a 5% discount coupon to try and save him. John gets the coupon and he quits anyway.
Because maybe price wasn't his problem. Maybe he hated the customer service.
Exactly. The model was perfectly right. That's technical success. But the business intervention entirely failed. That's a business failure. The key performance indicator, the KPI, was reduced churn. But the churn didn't move at all.
So phase I requires you to define that KPI target explicitly. You have to write down, we want to actually reduce churn by 10%.
Yes. And you evaluate against that later. If the model works perfectly but the KPI doesn't move a single inch, you have to change your business strategy, not necessarily retrain your model.
Okay, everyone stick with us, because we are entering the real heavy lifting now. Task Group 5, Trustworthy AI Requirements. The source material explicitly marks this as critical priority.
This is Domain 6.6 in the eco. And frankly, this is where the entire AI industry is finally starting to grow up.
We talked in the intro about how this isn't just an end-of-project checklist.
Right. The golden rule you have to remember is phase I defines these requirements. Later phases implement them, validate them, and monitor them. But you absolutely must define the rules of the road before you start driving the car.
Let's walk through the tasks here, because there are a lot of them in this group. And for the exam, you cannot bundle them together. You have to know them individually. Let's start with task 1, use of trustworthy AI framework.
The lesson for this task is simple. Don't freestyle.
Don't freestyle epics.
Exactly. Do not let your engineering team sit in a conference room and philosophize over pizza about what fairness means to them personally. That is a legal and PR minefield waiting to explode.
So what are you supposed to do instead?
You select a formal, established framework in phase I. Maybe it's the NIST AI Risk Management Framework. Maybe it's the OECD principles. Or maybe it's a specific, highly vetted corporate standard if your company is large enough to have one. You physically point to a document and say, we are following that framework.
Task 2 is required ethical AI considerations. This feels like the bias conversation everyone is having right now.
It is the bias conversation, but specifically in phase I, it's about proactive bias detection. You have to document the historical risks before you ever touch the data.
Give me an example of what that looks like.
Let's say you are building an AI tool for HR to screen resumes. You plan to train it on 10 years of your company's past hiring data.
Okay, sounds logical.
In phase I, you have to formally state, warning, our past hiring data is highly likely to be biased against female candidates because we historically hired mostly men in engineering for the last decade.
You explicitly flag it on day 1.
You flag it early, because if you flag it in phase 1, the data scientists know they need to actively look for it in phase 2 during data preparation. They can use techniques to intentionally rebalance the training data. If you don't flag it early, they will just throw all the raw data into the algorithm, and the model will perfectly learn to automatically reject women.
Wow. Okay, task 3 is AI failure modes. How's this different from a standard project risk assessment? Every PM knows how to do a risk matrix.
Standard project risks are things like the main server might crash, or the lead developer might quit and take a job at Google. Those are generic operational risks. AI failure modes are entirely about the cognitive brain of the system failing.
Like what? What does a brain failure look like?
Things like the model hallucinates facts and lies to the customer, or the model drifts over time because the real world changes and it becomes less accurate, or the model learns a spurious correlation that isn't real.
So these risks are entirely specific to the probabilistic cognitive nature of the technology.
Yes, and you have to brainstorm and identify these specific modes right now so you can build the safety rails later. If you know up front that a large language model might hallucinate, you know you have to build a secondary fact-checking layer into the software. If you don't identify the failure mode in phase I, you won't build the guardrail in phase 6.
Task 4, required compliance with regulations and laws.
This is navigating the legal landscape. Things like GDPR in Europe, CCPA in California, the new EU AI Act.
But why is this a phase I task for the project manager? Why not just let the legal department handle it later before launch?
Because data laws often dictate your entire technical architecture. If a European law dictates that data from German citizens must physically stay on servers located in Germany, you need to know that before your engineers design a centralized cloud architecture in Virginia.
Because if you build a massive centralized global data lake and then find out it's illegal,
You have to literally tear the whole thing down. That is a massive waste of time and millions of dollars. Phase I is about uncovering these hard constraints before you spend money.
Now, here's a pair of tasks that I know constantly confuse people studying for this exam. Task 5 and Task 6. Transparency versus explainability.
Ah, yes. The twin towers of confusion.
We really sound like synonyms in plain English. If I say I want the system to be transparent or I want it to be explainable, aren't I asking for the exact same thing?
No, absolutely not. And on the CPMAI exam, treating them as the same concept is a guaranteed wrong answer.
Break it down for me. Clear it up.
Let's start with transparency, which is task 5. Transparency is system-level visibility. Think of it as the nutritional label on the side of a box of cereal.
Okay, I like that analogy.
It tells you the facts. What is this system? Who built it? What specific data sets was it trained on? When was it last updated? It is entirely about openness regarding the mere existence and the broad parameters of the AI system.
So if I go to a customer service chat and the very first message says, "Hi, I am an AI chatbot trained by company X," that is transparency.
Correct. You're being transparent that an AI is in use. Now, explainability, which is task 6, is output-level visibility. It answers a very different question. It answers, why did the model make this specific decision in this specific instance?
Like, why did you deny my personal mortgage application?
Exactly. Why was I, John Doe, classified as high risk today? Transparency tells you how the system works generally. Explainability tells you exactly why it did what it did to you specifically.
That is a massive distinction. So transparency is the owner's manual. Explainability is the mathematical justification for a single choice.
Perfect way to remember it.
And finally, for this massive trustworthy group, there is an eco-addendum regarding privacy and security.
Yes. This ties directly into Domain 6 obligations. Specifically, we need to talk about identifying PII, personally identifiable information.
Names, addresses, social security numbers.
Right. You have to identify right now if your data contains PII, because if it does, you have to establish anonymization requirements immediately. And then regarding security, we have to talk about the adversarial attack surface.
The adversarial attack surface. That sounds like a plot from a sci-fi hacker movie.
It sounds incredibly cool, but it's actually terrifying for security teams. It basically asks, how could a malicious actor intentionally trick this AI? For example, could someone put a specific geometric sticker on a stop sign that makes the self-driving car's vision model think it's a speed limit sign?
Wait, is that a real thing? Can a sticker really do that?
That is a very real thing. It's an area of study called adversarial examples or data poisoning. In phase I, you have to assess if your system is vulnerable to being tricked by its inputs. If you are building a secure facial recognition system to let people into a bank vault, the answer is yes. You are a target, and you need to plan for adversarial attacks right from the start.
Wow. Okay. Let's take a breath. We have defined the business objectives, the cognitive needs, the resources, the metrics, and the entire ethical landscape. We have massive stack of requirements sitting on our desk. Now we reach the final gate of Phase 1. Task Group 6, AI Go No Go. This is marked critical priority.
This is it. This is the absolute moment of truth for the project.
Explain the core concept here. Is this just like a weekly status update meeting?
No, it is a hard, formalized decision gate. The ECO explicitly says you must conduct AI Go assessments. This is where the project sponsor looks at everything we've uncovered in Phase 1 and decides, do we proceed and fund Phase 2, or do we kill the project entirely?
And to make that massive decision, we use a study heuristic called the feasibility triad. 3 specific dimensions.
Right. Business feasibility, data feasibility, and execution feasibility.
Let's take them one by one. Dimension 1 is business feasibility.
The core question here is this actually worth doing? Do we have the budget? Is the value proposition crystal clear to the stakeholders?
What's the common failure mode here? What blinds people?
Mistaking executive sponsor enthusiasm for actual business feasibility.
Oh, like when people say, well, the CEO really wants it, so we have to do it.
Right. Just because the boss is excited after reading an article in Forbes doesn't mean the math actually works for your company. Remember that cost-benefit analysis we did in Task Group 1? If the time to ROI is 5 years and the startup's financial runway is only 2 years, it is absolutely not business feasible no matter how cool the CEO thinks it is.
Makes total sense. Dimension 2 is data feasibility.
Do we actually have the data we need? Is it physically accessible to our team? Is there enough volume to train a model? Is it legally permissible to use?
And this is where we really need to talk about the difference between pilots and POCs, right? Proof of concepts.
Yes. This is a huge concept for the exam. This is often where a conditional go happens. Sometimes you reach this gate and you genuinely don't know if the data is good enough to solve the problem. If you don't know, you cannot say, go for the full multi-million-dollar project.
So what do? You just give up?
No, you launch a POC, a proof of concept. A POC is a purely exploratory contained test. Its only goal is to answer the question, is this mathematically feasible? It is not a mini product. You are not giving it to customers. It is just a science experiment.
And how is that different from a pilot?
A pilot is a limited production deployment. It asks, does this work in the real world with real users? You do a pilot after you already know the math is feasible. You do a POC to find out if it's feasible in the first place.
So if data feasibility is a giant question mark during the Phase I Gonna Go meeting, you trigger a POC to get the answer.
Exactly. You fund the POC, not the whole project.
All right, dimension 3 is execution feasibility.
Can we actually pull this off as an organization? Do we have the necessary skills on staff? Do we have the cloud infrastructure?
This goes right back to that citizen data scientist versus actual data scientist conversation we had.
Right. If you decided you are trying to build that totally custom cancer detection vision model from scratch, and your entire current team consists of 3 business analysts and a summer intern, you have 0 execution feasibility.
So you really shouldn't rely on implicit feasibility.
Like saying, oh, the engineers are smart, they'll figure it out as they go. No. If you do not have the guaranteed compute power or the specialized talent locked in, it is a no-go, period.
And the decision rule for this final gate is incredibly strict, isn't it?
It is a logical A&D gate. You must have a go on all 3 dimensions to proceed to Phase 2.
So if business feasibility is yes, data is yes, but execution is no.
That is a no-go.
What if business is yes, execution is yes, but data is no?
Still a no-go. You absolutely cannot proceed.
That is tough. It really feels like the entire point of Phase I is actively looking for reasons to say no to the project.
We absolutely are. And I think that brings us perfectly to the closing thought for today's deep dive.
What is the ultimate? So what a Phase I, and why did we just spend an hour on this?
Phase I is entirely about preventing the most common cause of AI failure in the world. We talked about it at the very start of the show. Building the wrong thing, or trying to build something that physically cannot be built given your constraints.
It's an insurance policy.
And it really is. For the CPMAI project manager, all this work in Phase I is not just bureaucratic paperwork. It is your insurance policy against a disaster.
And I want to leave the listener with a thought that we discussed in prep for this show. As project managers, we are deeply trained to think that project success means launching the final product.
Right. We all want to cut the ribbon and pop the champagne.
But in Phase I of an AI project, success looks completely different.
It does. The most valuable decision an AI project manager can ever make is often to kill a project in phase I.
That sounds completely counterintuitive to everything we're taught.
Think about it logically. If you identify in phase I after spending only 2 weeks and minimal budget that the necessary data simply doesn't exist, and you aggressively kill the project right then and there, you just saved the company $500,000 and 6 months of entirely wasted engineering time.
You are secretly a hero.
You are. A no-go at this gate is a highly successful phase I outcome. It proves the methodology actually works.
That is a remarkably powerful reframing. Don't be afraid to be the one who stands up in the room and says stop.
It is always better to stop safely at the starting line than to crash dramatically at the finish line.
Thank you for diving deep with us today. We have thoroughly covered the objectives, the cognitive mapping, the resources, the metrics, the ethical landscape, and the final critical decision gate. You now have the complete blueprint for business understanding.
Now go use it on your next project.
We will see you in the next deep dive.